Okay.
Okay.
So my name is Dalia Malkhi. I'm a researcher from Silicon Valley Lab.
I'm sorry, I can't hear you. People in the back, quiet down. Go ahead.
Thank you. Again, my name is Dalia Malkhi. I'm a researcher from the Silicon Valley Lab. And I'm going to talk about the Nocturnal system, which is work done jointly with, starting with our summer intern, Kobe Fernandez, was the main architect of the system and still continues collaborating with us on this, and with Lidong Zhao from SVC, and thanks to Udi Witter, who helped with the TechFest demo and presentation as well. So in a way, Nocturnal is somewhat orthogonal to the approach. You guys are taking the Max approach, but hopefully there's something interesting in it, and I don't know, you chose it for this demo Blitz, so maybe there is some intersection. So the basic belief in Nocturnal is, I think, shared by a lot of people in Microsoft and outside Microsoft, and is very simple. We like to take advantage of social connections, social communities, bring information from those social communities to enhance the way we organize and search information on the web. So to take a very lame example, if I'm looking to buy dahlias and I search for that information, presently if I go to MSN search and I search for dahlias, I get a lot of irrelevant links, maybe some web spam, nothing related to my homepage and anything professional having to do with me. And I think the belief that we share is that the future of web search will leverage and will take into account context, personal preferences, and also information that we share with our community. So if someone in my social community, maybe a neighbor, maybe a friend, has bought recently dahlias and has some good experience with that particular vendor, that information carries a lot of weight to me. First of all, it disambiguates the information. So if he visited my web page, that may be related to what I'm actually looking for. But it's also in the way of recommendation for better shopping, better entertainment, things like that. And it could be a neighbor that I don't even know personally, or a neighbor of a neighbor. That carries a lot of importance to me. And probably if I know that someone down the street bought dahlias just recently, that is so much more important than any global ranking than a search engine can give me. So that's a vision shared by many. But the problem is, how do you harness that power of social communities, and how do you bootstrap that? And that is difficult. A lot of sites try out there, and to a certain degree they succeed, but I don't think there is one particular successful site that encompasses all global communities. You mentioned Delicious, you can mention, you can think of other, MySpaces, other sites. I don't want to put down any of the other efforts. None of them has become the standard de facto. And the fact is that it's difficult to elicit information from users about their hobbies, about their preferences, to get them to put all the relevant information out there, to subscribe to these services. And also, even if they did, these communities are separate. They don't share information. So maybe someone in my skiing club actually also likes dahlias, but I would never go to my skiing community and look for that information there. So there's really no good overlap there. And what we're trying to do is let this information propagate more effectively and more automatically on the network. So the basic idea that we have is very simple, and the system we've built is also really not that terribly sophisticated, but I think a very simple idea here can go very far in terms of use. So the basic idea is to harness the power of an existing social network, and here at Microsoft we have a great, the second largest social network in the world, the Messenger IM network, and it gives us a very natural way to construct communities. So if I look at my Messenger, my immediate contacts in Messenger, that's a very small but very closely coupled community. If I look at not only my contacts, but my contacts, that's already a somewhat effective, sizable community. So we looked at the Messenger graph data, and the average community size, 2-hop community size of a messenger user is already 500 people. If you look at 3 hops, it's already in the order of 10,000 people. Yep?
1 hop is my friends. They're friends is friends. They're being some way that they're friends. 3 hops, do you think it's still?
So I not only think so, there, I do have my personal view. I think that a 3-hop or a 4-hop community is just about the right size of community for you, in the sense that it's both under your control. You won't find any spammers 3 hops away from you. You won't find any malicious players there. There's a lot of, it's closely tied to you on the one hand. On the other hand, it's sizable enough that it will contain a lot of information, not just things that you know about anyway. So that's not only my personal belief and based on some experience I have with sites like Delicious or Flickr or things like that, but also we did a little bit of mining, and that's ongoing research that we're doing over the messenger network graph. If you look at my 3-hop neighborhood, and we did that experiment, I don't have that on slide, but we showed it at TechFest. We looked at a 3-hop neighborhood on the messenger graph and asked the question, well, if you remove me from my 3-hop neighborhood and look at the remaining members in that neighborhood, how many of them are still connected within 2 hops for one another? Well, it turns out 93% of them still are. And you look at things like clustering coefficient in...
Just my gut would have been, that's the data, my gut would have been that there's at least 1x per
3-hop?
Yeah.
No, really. So you have... So these are messenger concepts, it's not... Maybe yours. I don't know.
Jason is in my 1-hop network. That's the issue.
Okay.
That says that they're still connected.
Right. No, I would say 6 to 15 hops away, you'll start finding junk. But definitely not 3 or 4 hops away. On the other hand, 3 or 4 hops away, you already find something like 10,000 people. And again, my own personal experience with mailing lists and various such social communities is that a community of 10,000 people is just about the right size. You can find anything you want. Recommendations for babysitters, doctors, hotels, vacation results, and no junk. I mean, really very, very little irrelevant information there. So, if you accept this approach, and you could, of course, argue with it, what we offer is to leverage the existing infrastructure without any extra effort on the user part, without any explicit subscription or telling some site what your hobbies are or what your preferences are, or subscribing to a particular mailing list. Just taking advantage, leveraging the existing infrastructure, and sharing information over the messenger network. And so Nocturnal is a system that's built essentially of 2 parts. The first part is a generic information sharing infrastructure that is built over the existing messenger network and allows users to share information with their communities. The way this is done is a messenger user shares information with her contacts, her immediate contacts. That information is stored locally in the user's disk, in her PC, and is forwarded to the contact's contacts and to the 3-hop contacts and so forth. All information is tagged with the social path that it comes from and distance it comes from. The further it comes from, the less important it is. The less important it becomes, and the tagging loses, depreciates the importance you give it, and it's stored locally in a personalized manner. So this is the first part, and the second part is what we use this infrastructure, this generic information sharing infrastructure for. So the application we have in mind and that we've built with it is an enhanced web search browser. Basically, we have our own Explorer toolbar, a tool that enhances Explorer so that we can search through our toolbar the web. we obtain results back from MSN search and filter them, reorganize them based on information we find in the database. So we use the information sharing network to share recommendations about web pages that you visit and propagate them, gossip about them with our natural automatic community. So there are two ways, I'll show you in a quick demo in a minute, but there are two ways to pull information from you about web pages that you like. One is if you mark them in your, if you bookmark them, if you put them in your favorites, we assume you like them implicitly, and we also take the folder name that you file them under and use that as a tag. And there's also an explicit way where you can provide ranking and ask to share a recommendation about a page. So let me, at this point, move to a demo, and I have to kind of confess at this point in advance that what I'm going to show you is basically something that I did, before this demo started, and this morning. I'm going to show you the effects offline. Right now, it's broken, and I have an idea why, but I don't want you to get the idea that the system is not working. It's working, but I think I know what happened. I just don't want to deal with it right now. So basically, what I'm going to do is I'm going to open a remote desktop. Whoops. To my machine at the Silicon Valley. And here is a Internet Explorer enhanced with our Nocturnal toolbar, which is the bottom part here. And there are a few buttons here allowing you to click a warning on a page you like or to give it a rating, 1 to 5 stars. There are some options that control who you share information with. These are all the contacts, the messenger contacts that this user has. And you can control various privacy and trust options on that user. And I'm going to go ahead and type my favorite query here. And like I said, this won't work right now with anything else, so you'll have to bear with me. So I'm going to search for Dalias. And using the Nocturnal toolbar, what you get are 2 columns for comparison. On the left-hand side are the standard results returned by MSN search. And on the right-hand side is the results reordered by Nocturnal. Right now, there's nothing in the database, so they're identical. But suppose that the page that I really like to use is the one down here, the dalia.org page. Okay, so I'm going to go ahead and click on it. This is actually live, so the only part that's not working, I'll point that out in a minute. This is actually working. So I like this page, and I'm going to go ahead and give it some rating. Let's give it 3 stars. Oops, I forgot to click share. So click share and click the 3 stars here. And if let me just click back and forth here, and you see if I go back to this page anytime in the future, it will show me that this page was already ranked 3 stars. And if I go ahead and click search again, you will see that now the Nocturnal search results will bring that page up first with higher importance, and it will actually tell me that the Nocturnal rating it has are 3 stars. And that's the reason it was brought to a higher importance. Okay, so a very simple idea to enhance the search experience. Part, and this part is the search browser part. Information is fed back from IE into a local database, capturing your satisfaction from various pages that you visit. This database is then shared through messenger links with messenger contacts and the contacts and so forth and so on, and propagate through the network. And so when any messenger user later searches the web using MSN search, information from the local database is taken into consideration, and the results are integrated with the local database, with information from the local database, and the result that's provided is collaborative and personalized. So basically what I wanted to show you right now, and this is the offline part that I did before, is if I now move to this computer, to this laptop, and basically I have a messenger user here sharing information with the messenger user I have logged on to my desktop. We're using, following TechFest, we're using the new messenger folder sharing facility as a channel for sharing information among users. So this is already sharing information, and you can see I have information. I have folders shared with other messenger users, which I use to share information about a Nocturnal, and these are all XML files capturing the web page recommendations from other users. And so now, if I go to IE here, and I click the same query, Dalia's, and I search for it, then basically the same recommendation that came up on my desktop of the Silicon Valley comes up on top here. This is the dalia.org page, and it's given a rating, which is the original rating assigned by the user at the Silicon Valley, but multiplied by some trust level that I gave it. And on the left here, you can actually see why a page was recommended to you. If I go and click on this page, I can click here and see why this page was recommended to me. So this page was recommended because the other Messenger user gave it a rating of 3 multiplied by the level of trust that I gave it, or the degradation factor, which by default is a half. So, oops. So the take-home message from this is this is very different from many of the other social community-based tools that you find out there. It's completely decentralized. All information is shared in a peer-to-peer manner. Information is stored locally. It doesn't go to any centralized server. It's completely under the user's control how far this information travels in this network, and from what distance you trust information that you pull and bring from the network. It's all under your control, and you can assign the appropriate trust level to that information. As a result, the database that each user stored is completely individualized. No two databases are exactly the same. So even if Phil and I are immediate Messenger contacts and we share information every minute or so, we synchronize, still the database on Phil's machine and mine will be slightly different because he multiplies everything he gets from me by some factor, and some recommendations may appear to be 1 hop away for me, and they're already 2 hops away for Phil, and so forth and so on. What we get is a local, reasonably sized database of recommendations, completely personalized to my own preferences and taste.
So it's a very interesting approach. That's not. It seems like you're optimizing, like, you're generating more traffic. So anybody waits the other approach would be every user has their own database. They rate it.
That would have, right, that might have an intolerable latency overhead if you do it online. So if you trade, well, searching is a big problem with Kazaa, and Kazaa is using a DHT today to guide that search. It's not just flood search. So it's here you don't know, you don't have a key that tells you what you're looking for. Right, so the early versions of Kazaa or Nutella used flooding, and that didn't scale. Current versions of Kazaa uses Morpheus. But the trade-off is storage, which is really cheap these days. So I store everything locally. I bring it overnight or in the background or whatever. I store it locally. And I don't think it should be huge. So if you have 10,000 people in your community and you're willing to bring information from a 3-hop away neighborhood, so 10,000 people, each of them, how many pages can they recommend? What is their browsing history? It shouldn't be a problem in terms of storage or in terms of communication, but you don't want to put that burden in the critical path of you click on something and wait for a result. That's probably not the right thing.
So in our world, we just have where every user has you could do it the same way.
And one of the problems that this solves is that all of these ideas, the groove ideas and now the max ideas, create equivalence classes. So I have my, let's say, family shared space, and then I have my, whatever you use, pictures shared space, whatever. All of these are equivalence classes, and no information is shared among them. I have to explicitly say, this is what I want to. If I share information with you, you share it with me. If I share information with Phil and I share it with you, then you and Phil share information. We're all in the equivalence class, and there's no sharing of information among classes. Right? You have to specify this is information relevant for my family. This is information relevant for my skiing buddies. But there's no way to automatically propagate information between these two. Whereas this is more of a natural notion of a community. Community is whoever you know and who they know, and these are the people you meet in social events anyway.
I think it's very interesting. It's very interesting. Exactly that. You send all the messages across, build up a little local database, and then you can app. Are there? I'm trying to map this back to Max. You're on track to doing that with the messenger. Is there a
We're talking to Messenger folks. Following TechFest, we've started using folder sharing and are providing them with feedback about our experience. And as a researcher, I can't answer any question about business plans.
So, are there other scenarios that are interesting that you would do the same exact thing before, except that it's not necessarily monitoring what the browser?
Yeah, it's a great question. I think the infrastructure we built, which is a gossip, a reputation system built with gossip. Basically, I tell you something, you assign a certain trust level with it, and it gets multiplied and degrades as it propagates in the network. That part is generic, and if you guys or anyone else has additional applications for it, shouldn't be any difficulty in using it. And that's the messenger part. And we thought a compelling application for it would be web search enhancement.
Because we've been having this problem where our data is in stores that have, or in spaces that have security at the topmost level of the space. So we have this issue that we want people to be able to comment on other stuff. And do that in our system right now requires you, whoever you want to comment, right access to this index. So if I give you read access to my public photos, you can't comment on it. You can make a private annotation in your own database of what that is, but I can never see that. And especially if later on when we have fewer public spaces where I manage the space that really is like space that everybody reads on the only author, we have that problem works. So the only thing that we think of doing to solve that problem is to build a big index, a big public index of public comments, and then that doesn't solve the problem. This is it, right? No, I agree. So the only way to do the true public comment thing is to let people do their comments privately, index them up, and then when I try to display a comment, I get this database and clear it back. We don't know how to do it. No, I know. I'm saying this would allow you to read-only way, because you don't have to do right access to the space. I have my space, I have my files. You're a buddy of mine. He's a buddy of yours. You see, right now in our world, you can't even see the world uses everything. It's comments. That sends a chat to all of your buddies. What I think. We just have a little separate on the side there. Everybody has have no, I know. I'm sorry. I feel like I know. I always no. I agree, but it's a nice one. Like a comment publicly. It's just great. Yeah. So we're very interested in talking about that. How what the experiences were when I don't know.
Okay, well, that's your call. All right, thank you.
Okay.
Yes.
So, sorry for the delay. My laptop decided not to wake up out of standby, so I had to reboot. So first of all, I have to warn you, so this presentation is not about some cool user scenario of sharing files or visualization, but it's something cool for developers and testers to make their life easier. So let's start with what it is all about. So we looked at how testing is done inside of Microsoft, and we found out that actually a lot of developers and of course testers write something called unit tests. So I don't know if in your organization you do write unit tests. You do. Okay, great. Then this is for you. Even better, because then I can help you even more. Okay, so yeah, unit tests are very common. And so what do you get today? So the only tools that are out there are basically management tools. So they help you to run the tests, and then you get nice green and red bars which show you how many pass and fail. But you still have to write the tests. So what exists are some basic tools which generate stubs for the tests, like when you know what mock objects are, then they create just wrappers for that. But you still have to provide the logic, what particular cases you want to test. And so people write unit tests for different purposes. So one is in the beginning to work out a design of a product, but then later on the bulk of the unit tests is usually written to get high coverage of the implementation, to get confidence that the implementation is actually working in the right way. So when you write unit tests, what is your main purpose? Do you want high coverage, or do you work out your design? Whatever. Good. Good. Mm-hmm. Very good. So if you want to get high code coverage, then you have to write more and more those unit tests. And our idea is a slightly more general concept called parameterized unit tests. And then we can automatically generate inputs for these parameters, which give you the high coverage. And what we've done integrates nice in other unit testing frameworks, so you can leverage, if you already have unit tests. So for those who don't know what exactly unit tests are, here's an example. So it's the whole idea is that it is a small self-contained test to begin with. So later you might also write bigger integration tests, but essentially the idea is to test one feature at a time. So in this example, an array list is created with a capacity 1. So an array list is a container with a variable size storing elements in a list. And then a new object is created, added to this array list to the end. And then in the lookup, we make sure that it was correctly added and can now be taken out. So that is an example of how a particular class might be tested. And something interesting to notice that this is actually often perceived also as a specification of what the product is supposed to do. So often you can just take a user scenario and code it up as a unit test, and then it's a statement about what the product should do. But it's really a very particular statement, because what does it really say? So when you create a new object and you add it to the end, then you can look it up again in a new empty array list. So what if you slightly deviate? What if you add 2 elements? Or what if you use a different value for the capacity? Then this doesn't tell you anything. So it's kind of a specification, but not a good one. And what's the solution to all of? So what can we do? The simple idea is to lift the concrete things up into parameters. And now instead of the specific statement, here we actually have a general specification saying for whatever array list and whatever object you have, when you add it at the end, you can look it up again. this is now really a general statement. And now, okay, if you would write that, what's the advantage? We still need to figure out what values to use here, right? And, oh, by the way, it wasn't actually wasn't correct, because the array list could have been null and then would have crashed. So what is new in parameterized unit tests is that you have to add some assumptions too, under which conditions something should hold. So let's look at this particular array list example. And here it turns out that when we look into the implementation line by line, that there are actually two cases that must be considered. So there's one case where we have enough initial storage to store an object. And then there's another case where we start out with not enough storage, and then another code path will be triggered, which has to reallocate the storage array. So two cases should be considered. And so now one could figure out that by hand. That is what you do today to get higher coverage. You look at the program flow and think about what test to create to hit that branch. And so what I will show in the following builds on something called symbolic execution or symbolic exploration, where this analysis can often be automized. And then the idea is that we do this automatic symbolic analysis of the program, where we basically run the program not with concrete values, but with symbols representing an arbitrary input. And that not only works for plain inputs, but also if the inputs are objects, and then we can generate mock objects. I will show that later. And this analysis considers all the cases that can happen, but not more. So we get a minimal number of case distinctions. So once we have looked at all the cases, we try to figure out what are concrete values that will trigger those cases. And once we have the concrete values, basically we get traditional tests which you can run and use to debug an exception is hit, and you can use them for fast regression tests, because the symbolic analysis comes with a price. It is not as fast as a concrete execution. So having concrete tests is also good to run regression tests. Okay, now I will just show you how this would look like as a user experience. Okay, so here is the example I had on the slide before. It's a slight modification that the capacity isn't really a parameter of the test here, but it's a member of the class for technical purposes. That doesn't really matter. And so in this example, all that I made a parameter is the capacity. It's not the array list itself. And now, how many cases do I need to distinguish in this case, in this scenario? And so what I'm doing now, I'm starting our symbolic exploration from within the studio, and I can point to this test method, and it will explore it. So now we have an interpreter of .NET MSR code in the background, which explores all the different cases that can arise. And we get something like this. So when the program executes, the array list constructor is called, and internally it checks whether the capacity is negative. So in fact, there's yet another case, which I didn't show yet on the slide, which triggers an exception, an argument out of range exception. Otherwise, if the capacity is not negative, then the program continues. And at some point, there's this case distinction, whether we have enough capacity or not. And those are the two cases I showed you before. So we not only get high coverage, but we can also find bugs. In this case, it's not a bug. It's actually normal behavior when you pass a negative value to the array list to throw an exception. So in that sense, that's just more coverage. But it could also have been a bug that can be discovered during the symbolic analysis. Okay. Just for later load something in the background. Okay. So in this example here, the inputs were just integers, but in general, how do we come up with the values that will trigger certain execution paths? And so first of all, we have a set of known constraint solving techniques. So you have seen the kind of constraints that arise along program executions. But often the constraint solving techniques are not intelligent enough to figure out what the values should be. So sometimes the user has to provide values, and then we can just throw random values at our constraints and see if there's a solution. And finally, for objects, we can generate mock objects. So today, we often write them by hand, and we can actually generate the behavior of mock objects. Let me show you how that works. So consider this example. So this is the actual code of the .NET formatting functionality, which takes a format string like that and turns it into the formatted string. And so in the most general version, this method takes several parameters, so-called format provider, then the actual array of characters or string, so the version with characters, and the arguments. And then it does something. And so what's now interesting is this interface argument. Because now we need an instance of that interface, and where does it come from? So that is where you would usually create now a mock object, but then, so this interface has a method, get format. Now you have to decide how your mock object should behave when this method is called. Now, how many cases do we need to consider to test this method? And so our idea is now to automate this process entirely, to figure out what behaviors of the mock object we should consider. So first of all, like you would do today, we generate stubs for the interfaces. For example, here it should have a get format method. And then inside of the stub, we just say choose a value that should be returned. And now, during our symbolic analysis, we will just choose a new symbol, which could be any value. So, like we did before for the parameters. And then, as usual, we build up the constraints, like you've seen before, over those symbols. And then we can solve them to get concrete representatives for certain execution passes. And then we can replay in a normal concrete execution the possible execution passes. So let me show you what we found. So if you just explore this method, append format, without adding any assertions of what it actually should do, many cases arise. And one of these cases is the following, where so we pass in a format provider, an instance of this mock type, and the other arguments don't matter. And the first time the get format method is called, we return a new object. And if you look back, how the result is used, so it is cast to this other interface, iCustom Formatter. And the assumption probably was that because here this type is passed in, it also returns something of the type. It was probably written in a time where we didn't have generics. But of course, this might fail. So, okay. I'm actually almost finished. So this will throw an exception, and an invalid cast exception, which the string builder shouldn't, at least you can specify it, and it's not an exception you want to specify. And that is just one case out of many. So the method is actually quite complicated, and we were surprised to find this kind of exception in heavily used .NET code. Okay, now I could show you a demo, but it would be basically just that it integrated in Visual Studio and maybe one big thing. So at the end, what we generate are normal unit tests like these, which just call the parameterized unit test. And now you can just run this generated piece of code and it will trigger one of the possible execution paths. So this is, after our generation, totally seamless, like you would have written a traditional unit test. Okay. Okay. So that is our technology. We are currently applying it on a variety of projects and product. For example, we want to test MS Build with this technology. There's always room for improvement regarding the constraint solving techniques, because once you move into a new domain with new kinds of constraints, then yeah, we need knowledge about how solutions look like. For example, if you heavily use strings and substring and index of functions, then we should have a dedicated procedure which knows how to construct strings which fulfill those constraints. So we are confident with the that with mock objects we can actually make this scalable. So because when you write unit tests, it's just a small piece of code ideally, and everything else is mocked out. Yeah. So we are still working on it. There's not yet a tool that you could download and run today. But if you're interested to invest some of your time to apply this on your products, then I think we could come together and figure out where it makes sense to apply it, and then we could help you to apply it, and then we will fix problems you might encounter during the way. But it's not yet polished and finished. Okay, that's it. Okay.
Yeah, I think that would help you a lot. Cool. Thank you very much.
Bill, do you want to have a few minutes for rest, or should we go
No,
on?
I think we're okay.
Okay.
I just want to
Okay.
get the fan going again before
Okay.
we started roasting hot dogs here.
Okay.
So, anyway.
Thanks everyone for long attention, and especially thanks for Phil for inviting us to this talk. In the following 15 minutes, I will talk about our effort in distributed SkyDrive, a reliable and efficient peer-to-peer storage system. We are in the group of communication and collaboration systems in MSR Redmond. The outline of the talk as follows. I will briefly talk about the motivation and talk about the architecture of distributed SkyDrive and its component. I will examine the basic component of presence monitor, adaptive erasure coding, operations, security consistent models, and summarized talk. Distributed SkyDrive is a pervasive storage which we are prototyping, and we collaborate closely with MSN SDrive team and also with Windows core file systems to build a reliable and efficient storage device. The concept is we want to share data among multiple machines, share data to close friends, and we want to do efficient backup. And we also want to do high-performance server. And we hope distributed SkyDrive will serve as a reliable and efficient peer-to-peer storage device for all those tasks. And our dream is to achieve reliable internet storage for everything and everyone running Windows in the world. There's a lot of prior works on basically distributed storage. Due to the time constraint, I won't go over all of them here. Some key difference on distributed SkyDrive is we use adaptive erasure coding for efficient and reliable storage, and we use a lightweight file consistent model for easy handling. Basically, the basic component of the distributed SkyDrive is unreliable. each fragment store is basically a storage on each of the peer machines. There's no guarantee, basically, the fragment in the store is reliable or the entire fragment store is reliable. However, we want to use tools, especially erasure coding and index server, to make reliability out of the unreliable store. There are several key components. One component is the monitoring service. The monitoring service basically monitors every fragment store to see whether the store is online and offline, and then calculate a reliability rating of that fragment store. This reliability rating can be determined based on what your SS model is. If your goal is to SS, then the reliability rating is basically in which probability the peer you SS is online. If the target is backup, you can allow a certain grace period as long as peer basically come online within a certain period, this data is good. And the presence monitor can be centrally implemented in our current version or can be distributed implemented. But just imagine, yeah. This is considered basically resource, basically for peer. Certain peer will be more resourceful, certain peer will be less resourceful. This can be definition on the bandwidth and on the storage capacity, but it's different from the reliability. Now, assuming each of the fragment store, we can attach a reliability rating on it. Then, the way to achieve reliability of a certain degree, for example, 6.9 reliability of 12.9 reliability, is use a tool called erasure coding. Basic idea of erasure coding is this. Say you have a piece of original data. Now you fragment this data into k pieces. And then you use mathematical tools to code this data into n pieces. And k and n can be quite different numbers, and to achieve different rate of reliability. Now, at the time of retrieval or at the time of restore for backup, as long as you can find the k pieces in this n piece, you can reliably recover that data piece. This is basically the tool of erasure coding. If you actually go into erasure coding itself, there's a number of different erasure codes you can use. One code is random linear code, also called network coding. Avalanche in the basically MSR has been using this for peer-to-peer file sharing, and network coding actually is pioneered by Yunnan and Phil in our team. Another possible erasure coding is Solomon coding, which is a well-known tool in basically the community for basically to recover data. And in disk storage, there's also other code, basically RAID 6 code, for example, even odd or star code to recover a certain amount of fixed errors. Due to a time constraint, I will not go into details about the capability of each tool. But here, just some highlight. For network coding, the key advantage is low fail recovery cost, which means if your fragment store fails quite frequently, and the traffic used to recover this is important, then it can be a good code. The throughput of the random linear code, the network coding, is pretty good. It's on par with Solomon, with our basically some of the recent work by Charles and Christine in the security group. And the key problem of the network coding is this too. The overhead is relatively high because it needs to basically record what are the components which basically generate this code. And also, you cannot use systematic code version of the network coding. A second tool which is possible is Solomon code. Solomon code is well understood in basically its implementation. If you want to use it for a high replication ratio case, basically your store isn't very reliable, so basically you need to create more copies, then the throughput of this code is around 400 megabits per second. If your store is pretty reliable and you only need to create something like 2 to 3 copies, the throughput can be something like 2 gig to 4 gig. And security is relatively easy to do. Generally, in case the fail recovery isn't a key issue, basically your storage device doesn't fail that often, it's actually a pretty good code. And you can see basically the throughput can range depending on what kind of ratio you are using. And these are another class of code, basically RAID 6 class of code. The key advantage of those code is relatively high throughput. Generally, it's about double of that of Reed-Solomon code. The key problem is it's very limited. Basically, it can only recover about 2 to 3 errors. These codes are generally a more advanced version of the XOR operation used basically in RAID 5. It can be used for in a corporate environment where extreme high throughput is an important issue. Now, erasure coding can take 2 basically forms, systematic and non-systematic version. The key difference here is this. Recall that when we do erasure coding, we split the original data into k pieces, right? If the code is non-systematic, then all the code pieces is coded piece. You don't have an original data. Now, if the code is a systematic portion, then the first k piece is just the original. Then you have coded data. What's the advantage of systematic versus non-systematic code? The advantage of the systematic code is that if you want to do random access on the file, you can basically do it with relatively low cost. If you just, let's say, want to access this portion of the code, you can just grab it here. If it's a erasure, basically non-systematic code, you need to grab k pieces and do a decoding. And also for backup, if you just want to do a file level backup, a systematic version of the erasure code can achieve very efficient backup performance. Imagine this. Let's say, you all have files, and you want to create a reliable backup for all those files across all your machines at work. One way of using the systematic erasure coding is let those blocks be just the files in your current system. And then I will match up and generate those basically protection piece. Because I'm using actually the files in your current file storage as the code, basically original pieces, I can relatively efficiently basically use a very small storage to guarantee the reliability of your data. We just talk about erasure coding in terms of basically schemes, random linear versus Reed-Solomon and RAID 6 code. There are other erasure parameters. An important parameter is the fragment size. How many pieces you skip it to. The fragment size is important because of the replication ratio. Imagine now you want to achieve a certain level of reliability. The figure I use is 6.9 reliability. But of course, you can use whatever figure to basically plug into the equation. Now, if the individual storage is about 0.5 reliability, this is the typical reliability in the peer-to-peer file sharing cases. So let's say we are using MSN Messenger, and I assume most of people basically log online most of the time. This is about the reliability I would expect for the user. Now, when each individual peer is only 0.5 reliable, if I want to achieve a total of 6.9 reliability, and with replication only, I will need something like 20 peers. So that basically when I assess, I just need one from these 20 peers, and the statistic would tell me, well, this is 6.9 reliability. Let's see what happens if we use erasure coding. Recalling erasure coding, we first split the piece, basically file into fragment, right? And then we will put the files into basically more pieces, and then do retrieval. With different fragment size, the replication ratio achieved is different. So for example, to achieve the same 6.9 reliability, if the fragment size is k equals 8, the total amount of replication ratio is about a little bit less than 6. So in other words, I will split each file into 8 pieces, generate total of 6 replication copies, which is 6 times 9 equals 48, and store all those pieces into peers. Then I achieve this 6.9 reliability. Now what happens if I split the file into more pieces? If I can afford to split the file into k equals 256 pieces, then the equation told me that the replication ratio needed is about 2. So in other words, I only need something like 500, it should be 2.5. So I only need something like 650 pieces, which is a total about 2.5 times of the storage to do this retrieval. Now, I mean, again, the actual number can vary, depends on basically what kind of peer reliability and total reliability you need. But in general, the more fragments you split the file, the basically smaller replication ratio you need. However, should we just split file into more pieces? No. Simply because, I mean, for small files, split a file into a lot of pieces create overhead. And there's overhead in store those small fragments, and when you retrieval, if you need to go to a lot of different machines to retrieve a file, it also is a quite overhead. If we consider the overhead, the picture will be something like this. The system will tell you if your file is below a certain size. In this case, I believe the overhead, I assume, is something like 16K. So if the file is below 10K byte, it's not worthwhile to split the file. It's better for you just store the file in one place. Sorry, I think the overhead is something like 1K. Now, when the file becomes larger, you can afford to store the file into more pieces. This is quite natural. If you are accessing, let's say, a 1 gigabyte file, I mean, the cost to split the file into something like 1,000 pieces and contact 100 machines, or let's say 1,000 machines to retrieve it, will not be that high. At least, basically, it's amortized. And the benefit you get by using a small replication ratio really helps you. So the key basically ideas we have. Is we want to do adaptive erasure coding. We will measure the size of the file and basically consider your access scenario, whether you want to do just backup or you want to let the file to be accessed by other people. Then under this scenario, we will select the right fragment size, ERC method, and the right number of replicas, and allow this file to be stored reliably in the storage. The operations in the distributed SkyDrive is quite like a source depot operation. You have check-in and check-out. When you check in, file fragment is stored in this basically storage. And then it updates the index server, basically tell you this thing complete. When you check out, you talk to an index server, which access multiple machines and get back. There's additional operation, which is fail recovery. Assuming basically the index server will always monitor the storage to see if any of the node basically becomes bad. And you can have different definition of the bad basically for evaluation. Let's say when this node is bad, and this is one part of the cluster of multiple machines. What happens is the index server can instruct another machine to to regenerate copies from the existing copy in the network. This regeneration need to be done using K copies if you use not network coding, and it can be just 2 or 3 copies if you basically just use erasure coding. Okay. Okay, we'll do that. No problem, no problem. And you can see basically this is 2 models for distributed SkyDrive. If you basically try to do efficient access of the file, you will actually split the file into K pieces, store the piece in the network with its backup copies, and then basically at the time of retrieval, the basically system can retrieve different copies from the network. Because you have multiple copies located on multiple machines, when the bandwidth of the machine is relatively a bottleneck, this kind of model can speed up your access. Or imagine you are using it in the internet. Each machine will have a limited upload bandwidth. And especially in today's network, the upload is much smaller compared with download. Now, because of the fragment is in different machines, when you do download, well, you can use aggregated bandwidth from multiple machines to speed up your access. If your only concern is backup, then what can do is you can use the file, the entire piece of the file in the storage. So basically, you can just basically use the files already in your drive as a fragment. The index server's basically job is to find matching file fragment about the same size and the age, create backup copies, and then basically record those backup copy in the index server. We consider some of the security issues, which is quite modeled in the NTFS. And another issue we consider is basically the consistency. And the consistency, what we do here is we decide not to take very strong consistency like a Farsight, which is basically a file system. The problem there is, the cost is just too high. We adopt more a source depot-like operation. What happens is for each file or directory, we will attach a version number. This version number can be a date or hash or signature, and we use some additional information, basically whether anyone has checked out this file for write, and a past version chain for consistency measurement. This is the structure of the distributed SkyDrive. So for files, you can have multiple versions. And if you have directory, it can also have multiple versions with point to multiple version of the file. The main operation on the drive will be like a source depot, which I assume a lot of you have been very familiar with. You can check out the file for read, which basically take a snapshot of the file. You can check out the file for write. Basically, you check it out, and you mark it that basically says, I want to write on it later. And when you check in a file, basically write in, you try to update the version chain and see if there's any conflict. We have a flag, basically says, we'll check out. The key thing is this: when you check in, when you check out, there's no conflict. When you check in, you basically try to see if there's a conflict, meaning basically 2 people modify a file from same versions. If you find out, you basically just flag them out. The key thing is we will actually want the user to try to resolve this conflict rather than for let the system resolve. So the user basically will try to detect this inconsistency. And if there's 2 versions of the file, just put these 2 versions out in the directory. Yeah. If it can be serialized, or if it cannot be serialized in this basic consistency, it will just say, okay, this is version 1, this is version 2.
So it's index over text.
Yeah. It's not distributed conflict detection. which makes things much easier.
So give us a quick summary, because I'm going to get to these parts.
Okay.
So sorry about that.
No problem, you see. In general, we make efficient and reliable distribute basic storage, and we want to provide ubiquitous and secured content backup and retrieval.
Is this available right now? I know you said you're working with MSR. What's
The
the status?
status is we are making prototype. I mean, we haven't implemented everything yet. We have a very crude prototype, basically doing this check-in and check-out interface. And if you're interested, we can talk to you to see what component you might be interested. Yeah. I probably need to, in the storage space, there's really a lot of basically works. I cannot remember right now total recall is being done by which basically group. We can talk basically on see what's the basic technology difference there or here, and we can discuss later.
It sounds like there's maybe some opportunities.
Well, we've been in conversations with we are definitely interested in replicating our data to your file.
I think I got the last demo slot of the day, so I'll try to move through my stuff pretty quickly since I know it's a pretty long day for you guys. So I'm going to talk about Bartok, which is a compiler and runtime system for native managed code. This is a reprise of the TechFest 2006 demo. So I'll just give you a brief motivation. So at the TechFest, we're also presenting Singularity, which is an operating system written entirely in managed code. And so the motivation for this demo was the typical questions we get are like, hey, what'd you guys do to the CLR? Where'd it go? How does your operating system boot if you don't have the CLR, and how do you cross-compile? So that's the context which we did this presentation in. And so one of the key points, of course, is, yes, we actually have used this technology to write an entire research operating system in it. So what is Bartok? Bartok compiles managed code to native code. It supports the unsafe features too. It consists of two parts. There's an ahead-of-time optimizing compiler. And the basic point of that is we have more time for compiling so we can produce better code. And there's no runtime overhead, unlike having a just-in-time compiler. So in a server situation, this is probably a good thing. It has a lightweight modular runtime system. So the idea is the runtime system is minimal. So we only support the key features of managed code. It's customizable. And so, for example, you can choose the garbage collector on a per application basis. And you don't pay the cost of unused features. So if you don't use a feature, we can cut it out. And we can actually allow you to customize it and use a variety of libraries. And the point of doing this is that this is the kind of thing that if you're doing systems programming, you would be pretty interested in. So, the kind of thing we're envisioning, and we actually do use this thing, is to span all the way from device drivers all the way up to sort of higher-end systems. And particularly if you have lots of small processes running around, this lightweight modular runtime system is a good idea. The basic gist of it is to have something that actually works in the variety of settings that you need for systems programming. So what .NET features do we support? Well, we support most of the core .NET features. We support the core types and the object model. We support garbage collection, exception handling, lazy type initialization if you want it, delegates, platform invoke, unsafe code, the data layout attributes. The things that we don't support, and we don't support dynamic class loading, and we don't plan to support it either. We have very limited support for reflection, limited support for common op and code access security. One of the points I like to make about the other 3 points, reflection, code access security, and common op, is that for a product effort, you could have varying levels of support for this. So we were a research effort, so we weren't particularly concerned about, for example, common op. But if you're trying to use this for systems programming and you go talk to the Windows guys, they'll say, well, we need some form of common op. Now, it's not clear that we want the COM interop, for example, that the CLR has, where like any class can be turned into a COM object. I mean, that's kind of overkill, I think, for a lot of system settings, where you know there's only a few classes you're going to turn into COM classes, and you know this ahead of time when you built your system that this is going to be the interface. So in practice, on the product side, you could actually add sort of it's a knob you could turn there, depending on what you want to build. So how does this whole thing work? How do we compile managed code to native code? We start by compiling your MSIL, which is C# or C++, down to, or compiling to MSIL. We start with C# or C++, compile it down to MSIL. Then we can actually verify the MSIL and decide whether it's safe or unsafe. So for example, if you're prohibitioning your system against running any unsafe code, you can reject it at that point. And the reason why you might want to do that, for example, is you don't want to deal with buffer overruns. You don't want to deal with memory corruption, all that kind of stuff. That's the reason why you might want to stick with a verifiable program. Then we actually compile it down to native code. So we take the MSIL, we run it through our optimizing compiler. We get native object files. The object files can be either for x86 or x64. So that's something that's new since TechFest. We actually added x64 support. And then you link them, and out comes a native executable that you run. So this is a fairly familiar model if you're used to programming in C or C++. So we wrote everything in managed code. We did this in part, or we tried to write almost everything. There's a little bit of assembly language here and there that we had to use for the core runtime system. And the point was that, look, if you're really going to use this stuff, if you're really going to buy into using managed code, you should be able to write the entire system in managed code. And if you can't get the perf, then there's something wrong with your system and you need to fix it. So we wrote, the libraries, of course, are written in managed code, and we actually took a subset of the libraries and pruned out the cases where they used native code and replaced them with managed code. We actually have a couple of different libraries. We have one for .NET, and then we have a couple of different libraries for Singularity. So think about this. We can have different base class libraries depending on what your application is doing. Lightweight runtime system, it's mostly safe. We got rid of the garbage collector is obviously unsafe code at this point. We're actually working on research to eliminate that. And then, of course, your user programs. And you compile them again. This is the same model again. You compile it down to MSIL, down to object files, and then you get a native executable file. And this is the same model that you use for native code today. So the benefits, well, you can use Microsoft's managed languages for systems programming, and you get the safety and productivity. And hopefully, if we do this all right, you're going to get the performance characteristics you need for systems programming. And I'll actually point out that for Singularity, at least for something at the operating system level, we can get the performance characteristics we need. The limitations, well, the first thing I'll say is this is not a CLR replacement. It complements the CLR. There's going to be some scenarios where it doesn't work well. So, you don't really, ahead-of-time compilation isn't suitable for compiling dynamic scripting languages. You could do interpretation if you want to do that. You could certainly write an interpreter and run it in our system. And the environment is, at this point, not as rich as the CLR. In fact, that's, I believe, a selling point when you're trying to do systems programming. You want to sort of control the richness of the environment. And then there are some of the same issues pop up as native code, because the end result you're getting out of here is native code. So our extension models, DLLs. With versioning, you have to worry about the fragile base class problem, though there's some proposals floating around that could work around this problem that I think are fairly straightforward. CLR team's talking about some solutions to this. And then one point I'd like to make is that if you have untrusted plugins, I don't think native code is really the suitable distribution format for that, because you open up the door for all kinds of security attacks on your system. We're actually working on typed assembly language. We're an approach to fix this. The idea would be that we could distribute the machine code along with types attached to the machine code that would allow us to verify the safety of the code on the client machine, so you don't have to trust who's ever producing these plugins that they got it right. This is research. This is probably a couple of years out on the horizon. I don't think we'll use the next year. Probably 3 years. But our goal is to actually, in Singularity, implement this and use it for all of the user level processes in Singularity. And finally, the interop story with .NET would need to be worked out. So the question is, if you run our native code and you run .NET and you run it in the same process, what's the interop story? One of the points is the interop story could be a lot nicer than it is with C++ at this point, in that our language is garbage collected. .NET's garbage collected. Presumably, you could either have multiple garbage collectors or a single GC cooperating. But we haven't really put a lot of calories into working out that story. The basic idea, ahead-of-time compilation, the basic idea I want you to take away from that is just ahead-of-time compilation means better optimization, which means faster programs. So we do extensive optimizations. We do over 30 optimizations in the compiler. And if you were to actually carry this out and put this in a product side, I think the number of optimizations would go up. And the advantages, of course, in a server environment, if you're paying for server machines, more optimizations means hopefully fewer server machines if compute time is at all an issue. We can do whole program compilation as well. So we actually had a predecessor compiler called Marmot where we demonstrated whole program performance competitive with C and C++. We put a little less emphasis on the optimization side here and more on supporting systems programming in this system. So there's some optimizations in Marmot that we're missing now. But because we've got the whole program in some situations, because we've got rid of dynamic class loading, we can actually do a better job of optimizing things. And finally, we can automatically specialize the runtime system. So we don't want people to be in the business of hacking the runtime system code. We want the compiler to take care of this automatically. It's just not going to scale to have a large number of people hacking the runtime system code. So here's the picture of the modular runtime system. So it's pretty small. You've got your GCs, threading and synchronization, type tests, exception handling, interface calls, virtual calls, platform invoke, and then your core data types. And so reflection is gone, class loader is gone, the JIT is gone, security is gone, at least the code access security is gone. And in terms of the garbage collectors, for example, we let you choose, at this point, every time I give this talk, when people in my team are doing a good job, I cut to add another garbage collector to this. So you get to choose the right garbage collector for your application. So for example, if you're really worried about throughput and you're just sort of handling large batch data, you might want to use generational semi-space copying collector. If you're really worried about real-time performance, then there's a concurrent mark sweep, which will give you, I should say soft real-time. Anyway, it will give you much lower pause times, but at the expense of some throughput. And this whole thing, let's see, I think I actually I had to do a presentation the other week to some other executives in the company, and I counted the lines of code just to make the point that this is a small runtime system. So the total amount of code here was about 32,000 lines of code. Yeah, with all 7 garbage collectors. So now, I didn't really go in and, this is sort of a mushy one because .NET has all kinds of things to throw into the debate. So I didn't really spend a lot of time trying to count all the core data type lines here. So this could probably become much larger if you want it to be. But the rest of the system is fairly small. And it's all written in C#. So the status, so where are we actually with this thing? Well, we're working with product groups to try to get this into the dev-div product line. So we've been talking with the Phoenix team. We actually have a joint effort going with them, and the CLR team also trying to figure out how the runtime system story fits together. And I'll be really honest, if you guys are interested in this, it helps us to be able to go talk to them about your interest and why you're interested and how it might be valuable for you. I mean, at this point, we have a timeline. There are other groups in the company that are interested in them, but somehow I suspect your timeline might be shorter and faster than some of the other groups, which are thinking like, a little further out, 4 or 5 years out. So again, if you're interested in this, it would be really good for us to be able to at least have some discussions with the product groups we're talking with, just to say, why are you interested and what would its value be to you? We can actually do a demo if you want us to, but it's just showing us like compiling the OS kernel. I mean, Biana, who would do the demo, keeps saying, we don't need to do a demo. It's just showing them compiling. So we can do a demo if you want it, but it's been a long day. Okay. So I guess the thing I'd ask is if you have any questions at this point or comments or feedback about this. Yeah, if you actually know, so Avalon might be a problem. I don't really, they make heavy use of reflection, and I haven't gone through their code base, but if you actually know what classes you need ahead of time, we can mock simulate dynamic class loading. So if you actually, yeah, you just basically throw it all in and link it all together, and if it's there.
This would be like
yeah, no, that's, yeah. Well, but you have to be a little careful about that because we do, we have not implemented, but we believe we could support DLLs properly. So the appropriate thing in your situation would be you compile them all down to DLLs and you link the DLLs and do them. Yeah. Anyway, yeah.
Right now, you distribute MSI out. If you compile it down to native code, you're basically asking customers questions. If you're some executed code, we say it doesn't do anything bad.
Yeah, we have that. Well, yes, they do.
Okay.
Okay.
We're a full out install. That's
Okay.
another interesting thing. You might not trust them as well as you have.
Right.
Again, that would be a low. It's like we have the same thing. That's better for replicating policy. We like them to run continuously. Yeah. We also like running discussion. Right. And then we're not. Then we go like way to go serialization, especially running some sharp
Yeah, that's a. I mean, some of these problems may go away on our own without us doing anything. I mean, both Avalon and anything that makes use of those reflection features or dynamic class letting, I think that people are going to be looking pretty seriously at that. I know Avalon is thinking about their perf issues. So it would be really helpful for us. I don't know how you guys would want to move forward, but it would be really helpful to at least have one meeting or send us an email or whatever you want to do. I mean, I know you're really busy. Just because, for example, the scenario you just mentioned, which is taking managed code, compiling it to native code, and then shipping it onto the client, is not something that we had actually envisioned. And the motivation you're giving is you, for example, want to install services that are running continuously where the footprint and the overhead of managed code could be an issue. I mean, if you install 10 of these things, it's like 40 megabytes minimum down the toilet for your customer. And that yeah. So, but the thing is, like you said, you already have native. I think you already were saying basically you have native installs already, or you have.
No, I'm just saying we're an
Yeah.
XE.
Yeah. So you're an XE that you download. So. Okay.
We can't do our best.
Okay. And that's something, for example, that we never really considered that scenario. They care a lot about the sort of Windows scenarios that people are talking about. You're trying to use it in systems programming to make things, safer and have more productivity in your programming. What's that? These guys are thinking of it as a Visual Studio feature, but part of the, we should let the product groups answer some of your questions here. So, I mean, I'm giving you my impression, and yeah, that's the way they're thinking about it. But in terms of their customer scenarios, in terms of their driving customer scenarios, they're thinking about this in terms of systems programming like Windows components or people who are in your boat, but they don't really have a scenario in mind for people who are in your particular situation. Having you guys be the scenario they're thinking about would make it much more concrete. Their attitude is, right now, I think their assumption is that most people who write those apps who care about performance are writing in C++.
I wish I could do it in managed code.
Yeah, okay.
Like, who wouldn't?
Well, I'm glad. So,
Garbage collector.
yeah.
So it sounds to me like they should follow at least at the architectural level. And so you can have more arguments in the product group and at least on the dev side.
Yeah.
So,
Yeah.
you guys have the contact with the backer, but yeah, it's driven. Yeah.
Yeah, and the other thing would be after we talk some more and make sure we all understand things at perhaps a deeper architectural level, I would like to have one follow-up meeting with some of the people on the product side, or we could just do a follow-up email. But I think follow-up meetings are helpful just so that they understand your interest. And I guess the things they're going to be looking for is the level of interest. How much do you want this? And, that kind of stuff.
Basically, we're in a situation where we're really going into the future of compilers really trying to push the edge. And in some cases, the dev guys don't even have enough code like this. The kind of do is not to the extent that we would like to in terms of furthering the research.
Yeah.
We really have an eye right in this conversation. But obviously, if we can touch some other stuff, see what that we have a feedback back.
Like the market, people I didn't know what you used in your code. Yeah. Yeah.
So,
Yeah. Have a good day.
so what are the frameworks you're saying? You're using Indigo? You're using Tabular? What other large components? Those are things we don't support right now. But otherwise, we do support, writing your thing.
Those are really good. There's things like this. I doubt that.
Right.
There is a.
You can also totally call it.
How they do this.
Okay. Well, this was really helpful.